at inverses in greater detail, remember that the square root function is an inverse of the quadratic. So before we begin, let's look at inverses for quadratic and cubic functions. Guys, just remember what goes on with an inverse. So remember, when you have ordered pairs of 1, 2, 3, 8, 5, 9, and 10, 7, to find the inverse, all you do is switch x and y. So the inverse of this would be 2, 1, 8, 3, 9, 5, and then of course 7, 10 would wrap up the inverse points for this relationship. Let's skip this section right here. Let's go down to the bottom where it says finding and graphing the inverse of a quadratic function. So remember that the quadratic and the square root function are inverses from each other, and all inverses are a reflection over the line y equals x. Y'all, this is a test question. I would highlight this. So what we're going to do is we're going to take a look at the parent quadratic function. She's going to be all right. Just x squared. Oh, in a moment. I'll go back in a moment. So to find the inverse of this, so just pick up where we left off. So the inverse, we're going to follow these steps, guys. So we are going to drop f of x, and we are going to write y equals, so that's step 1. Step 2 is to switch x and y. And then step 3, or part C, is to solve for y. Guys, currently y is being squared. To get it unsquared, you will square root both sides. So the square root of x is going to equal a single y. Any questions on part C?
Yes. Why did the square stay, or why did the square go to the y instead of stay with the x?
We're finding the inverse right now. So we switched x and y to find the inverse of it. All right, y is completely by itself. Now we're going to replace y with the function notation that lets me know it's an inverse of something. You guys have to use the f to the negative first power with the letter x. So the inverse of f of x is f to the negative first power. And remember, that is the square root of just x. So if we look at this part right here, I kind of glazed over it, but we do need to talk about it. It's very important. We are going to restrict the domain for this parent function when we graph it. We are only going to graph positive input values, and I'll show you why. So what we're going to do, guys, is we're going to graph x squared, but only for positive inputs. So when I go to graph this, let me grab a different color. If I have an input of 0, the output is 0 squared. So the first ordered pair for this parabola is 0, 0. The next ordered pair, if I put a 1 for the input, the output's 1 squared, which is just 1. So the next ordered pair is 1, 1. Here's where it starts changing, though. When I have an input of 2, the output is going to be 2 squared, so the y-coordinate's 4. So this is 2, 4. And then what is the output for 3?
9.
Yes, good. And then can we fit any more points on that? No. So that's the positive side of the parabola. Y'all, let's connect the dots because it's an equation with an equal sign. And let's go ahead and draw the arrow on that. So for the inverse, we are now going to remember when you graph inverses, for the square root function, we're only going sideways a perfect square amount of times. So remember, if I tried to take the square root of 0, it is just 0, so the origin is still there for the inverse. If I have an input of 1, the square root of 1 is 1. So 1 is still here. And guys, remember it's right over there on that board. We talked about it yesterday. So if I have an input of 4, the output is going to be the root of that, which is 2. And then if I have an input of 9, remember your inputs have to be perfect squares so they show up nice on the graph. An input of 9 is going to have an output of 3. So your inverse looks like that. And you guys kind of already knew what that curve looked like, so we did it yesterday. But what I do want to point out is that it's reflected. X squared has been reflected across that line, y equals x, to make the square root function. Go ahead and draw that line and label it y equals x.